Good morning to all. Myself K. Pushpavali, Assistant Professor, Department of Mathematics. Today going to the topic is Allied Mathematics 1. Unit 1, Successive Differentiation. Subtitle, Leibniz Formula, Curvature, Radius of Curvature, some related problems. First one, Leibniz formula for the nth derivative of a product. This is two formulas. Find the first sum. Find the nth differential coefficient of x squared log x. Use equal to, consider to use equal to log x, v is equal to x squared. Use equal to log x, du divided by dx equal to log x, x squared, dv divided by dx equal to x, dn divided by dxn into u of v equal to formula dn divided by dxn log x into x squared plus nc1 dn n minus 1 divided by dx n minus 1 log x 2x plus nc2 t power n minus 2 divided by dx n minus 2 into log x into 2. dn divided by dxn log x equal to minus 1 whole power n minus 1 into factorial 1 power n x power minus n divided by x power n dn minus 1 log x divided by dx whole power n minus 2 equal to minus 1 whole power n minus 2 into n minus 2 factorial x power n minus 1 t n minus 2 log x divided by dx n minus 2 equal to minus 1 in whole power n minus 3 factorial divided by x power n minus 2. Then substitute the three equations equal to minus 1 whole power n minus 1 factorial divided by x power n x power minus 2 plus 2n minus 1 whole power n minus 2 factorial x power n minus 2 x power minus 1 plus n into n minus 1 minus 1 whole power n minus 3 into 2 divided by 2x power n minus 2. Derive the two steps. Next step, common numbers minus 1 whole power n minus 3 factorial divided by n minus x power n minus 2 into minus 1 whole power 2 n minus 1 n minus 2 plus 2n n minus 1 into minus 1 plus n into n minus 1 minus 1 whole power n minus 3 into n minus 3 factorial x power n minus 2. Therefore minus 1 square is equal to 1. Then multiply the n minus 1 and to n minus 2. Therefore n into n squared, n into minus 2 minus 2n, n into minus 1 minus n plus minus 1 minus 2 equal to plus 2 plus 2n into n minus 1 minus 1 2n into n equal to 2n squared 2n into minus 2 equal to minus 4n minus 1 plus n into n minus 1 equal to n into n squared n into minus 1 minus n minus 1 whole power n minus 3 n minus 3 factorial divided by x power n minus 2. N squared minus 2n minus n. 2n minus 2n minus n equal to in minus n minus 4n. There also minus 4n plus 4n. N squared plus n squared 2n squared. Then do minus 2n squared. Minus 2n squared plus 2n squared is equal to 0. Minus 4n plus 4n equal to 0. Therefore dn divided by dxn into x squared log x equal to 2 minus 1 whole power n minus 3 factorial x power n minus 2. Next sum, if y is equal to sine into m sine inverse x, prove that 1 minus x squared y2 minus xy1 plus m squared y equal to 0 and 1 minus x squared yn plus 1 minus 2n plus 1 xyn plus 1 plus m squared minus n squared into yn equal to 0. Proof. Given y is equal to sine into m sine inverse x. Sine inverse x y equal to m sine inverse x. There are equal to. Next, differentiate with respect to x. Differentiate sine inverse, differentiate 1 divided by root of 1 minus y squared. Differentiate is dy divided by dx equal to m also constant. So sine inverse x equal to differentiate 1 divided by root of 1 minus x squared. Then cross multiply for 2 1 root of 1 minus x squared dy divided by dx equal to m into root of 1 minus y squared. Squaring on both sides. 1 minus x squared root of 1 minus x squared whole power squared equal to root, cancel to root and whole squared, then equal to 1 minus x squared, and dy divided by dx equal to whole squared equal to m squared 1 minus also 1 minus y squared. Differentiate with respect to x. 1 minus x squared dy divided by dx differentiate whole squared differentiate 2 dy divided by dx. Next dy divided by dx differentiate d squared y divided by dx squared plus dy divided by dx squared whole squared equal to whole squared 1 minus x squared differentiate minus 2x equal to m squared 1 minus y squared is equal to minus 2y. Y differentiate equal to dy divided by dx. To dy divided by dx 1 minus x squared d squared y divided by dx squared dy divided by dx equal to minus m squared y. Take nth derivative on both sides. Nth derivative on both sides. Thereafter, formula for the Leibniz formula. Then 1 minus x power 1 yn plus 1 plus yn n plus 1 into minus 2xn minus x plus yn n minus n into n minus 1 minus n plus m square is equal to 0. Yn plus 2 into 1 minus x square minus yn plus 1 into 2n plus 1 yn minus n squared plus n minus n plus m square is equal to 0. Plus n in minus n also cancelled, hence the proof. Curvature. Let's denote the length of the arc AP measured from some fixed point A on the curve and psi the angle which the tangent makes with the x-axis as B moves along the curve S and psi vary and the rate at which psi increases relative. D psi divided by ds is called the curvature of the curve at the point P. Radius of curvature formula. Next sum. What is the radius of curvature of the curve x power 4 plus y power 4 equal to 2 at the point 1, 1 into P? Solution. Given x power 4 plus y power 4 equal to 2, differentiate with respect to x power 4 differentiate y x cube plus y power 4 differentiate 4 y cube, y differentiate dy divided by dx, 2 differentiate equal to 0. 4 is constant, common 4 into x cube plus y cube dy divided by dx equal to 0. X cube plus y cube dy divided by dx equal to 0 divided by 4 equal to 0. Y power 4 dy divided by dx, x cube equal to in the side minus x cube dy divided by dx equal to y cube multiplication in this side equal to differentiate with respect to x. D square y divided by dx square equal to minus y cube into 3x squared minus x squared into 3y squared dy divided by dx divided by y cube whole squared u squared uv formula, then equal to minus y cube 3x squared minus 3x squared y squared dy divided by dx divided by y power 6. Next equal to 3x squared y squared y minus x dy divided by dx divided by y cube y6. Next at 1, 1 dy divided by dx equal to minus 1 divided by 1 is also minus 1. Therefore y1 is equal to minus 1. Also y2 is equal to minus 6. Radius of curvature formula, rho is equal to 1 plus y1 square whole power 3 by 2 divided by y2. y1 is equal to minus 1, y2 is equal to minus 6. Substitute the rho radius of curvature formula, then rho is equal to root of 2 divided by 3. Next sum. If a curve is defined by the parametric equation x is equal to f of theta, y is equal to pi of theta, prove that the curvature is 1 by rho equal to x1 y double dash minus y dash x double dash divided by x dash squared plus y dash squared whole power 3 by 2. X is equal to f of theta, y is equal to pi of theta. Differentiate with y, x divided by dx divided by d theta into d theta divided by dx equal to divided by divided by dx equal to y dash divided by x dash. D squared y divided by dx squared also d divided by dx y dash divided by x dash. D squared y divided by dx squared in another way d divided by d theta y dash divided by dx dash dot d theta divided by dx. Next, differentiate y dash divided by x dash y dash differentiate y double dash minus y dash x differentiate x double dash divided by x dash into x dash whole square into 1 divided by dx divided by d theta. X dash y double dash minus y dash x double dash divided by x1 whole square into 1 divided by x square x dash d squared y divided by dx squared is equal to x dash whole double dash minus y dash x double dash divided by x dash whole cube. Next, radius of curvature rho is equal to 1 plus y1 divided by x1 the whole square whole power 3 by 2 x dash y dash minus y dash x dash divided by x dash whole cube. Then 1 plus y1 squared divided by x1 squared whole power 3 by 2 x dash y double dash minus y dash x double dash divided by x dash whole cube. Next, derive the two steps and then rho is equal to x1 squared x dash squared plus y dash squared whole power 3 by 2 x dash y double dash minus y dash x double dash. Therefore, 1 by rho is equal to change the up and down x dash y double dash minus y dash x double dash divided by x1 squared plus y dash square whole power 3 by 2. Next sum, find the p at the point t of the curve x is equal to a cos t plus t sin t, y is equal to a sin t minus t cos t. Solution, x is equal to a cos t plus t sin t, differentiate a t cos t, y is equal to a sin t minus t cos t, differentiate equal to dy divided by dt equal to a cos t a sin t. Next, dy divided by dx equal to dy divided by dt into dt divided by dx. Dy divided by dx equal to a t sin t divided by cos t equal to tan t. Therefore, dy divided by dx equal to tan t. Then differentiate d squared y divided by dx squared. Then differentiate tan t equal to secant square t 1 divided by dx divided by dt. Secant square t 1 divided by dx divided by dt equal to at cos t. Then 1 divided by at cos t. D squared y divided by dx squared equal to 1 divided by cos square t into 1 divided by at cos t. Therefore, 1 divided by at cos cube t. Radius of curvature formula 1 plus y1 square whole power 3 by 2 divided by y2. Then substitute the y1 and y2 values. Then p is rho is equal to at. Radius of curvature rho equal to at. Prove the radius of curvature at any point of the cycloid x is equal to a cos a into theta plus sin theta, y is equal to a 1 minus cos theta is 4 cos theta divided by 2. Proof, x is equal to a theta plus sin theta, dy divided by dx equal to a 1 plus cos theta differentiate sin theta differentiate cos theta, y is equal to a 1 minus cos theta, dy divided by dx equal to a sin theta. Next, dy divided by dx value is sin theta divided by 1 plus cos theta. Next, derivative d squared y divided by dx squared equal to d divided by dx into dy divided by dx. D divided by dx into sin theta divided by 1 plus cos theta. D into sin theta divided by 1 plus cos theta into d theta divided by dx divided by d theta. t into differentiate into sin theta divided by 1 plus cos theta divided by sin t theta into 1 divided by dx divided by t theta. Therefore, uv method, u is equal to sin theta, v is equal to 1 plus cos theta. Then differentiate d squared y divided by dx squared equal to 1 plus cos theta into cos theta minus sin theta into minus sin theta divided by 1 plus cos theta whole square minus a 1 plus cos theta. Cos theta multiplication to 1 into cos theta equal to cos theta. Cos theta into cos theta cos squared plus sin into sin plus sin squared divided by 1 a into 1 plus cos theta whole cube. 1 plus cos theta cos square theta plus sin square theta value is 1. Then 1 plus cos theta divided by a into 1 plus cos theta whole cube. Then t squared y is divided by tx squared value is 1 divided by a 1 plus cos theta whole cube. Then radius of curvature rho equal to formula 1 plus dy divided by dx whole square whole power 3 by 2 divided by d squared y divided by dx square 1 plus into sin theta divided by 1 plus cos theta whole power 3 by 2 divided by 1 divided by a into 1 plus cos squared. Next, derive the 3 steps. Let's see. Next, 1 plus 2 cos theta plus 1 whole power 3 by 2 divided by 1 plus cos whole cube into a into 1 plus cos theta whole square. 1 plus 1 is equal to 2 plus 2 cos into cos equal to cos squared whole power 3 by 2 divided by 1 plus cos theta then cos cube theta, so cancel to the cos squared theta 1 plus cos squared theta. 2a derive the 2a power 3 by 2 plus 1 plus cos squared theta whole power 3 by 2 divided by 1 plus cos theta. 2a 3 by 2 into 1 plus cos squared theta whole power 3 by 2 minus 1. Next, derive the 3 steps. 2 squared a cos theta by 2 rho is equal to 4a cos theta by 2. Therefore, radius of curvature rho is equal to 4a cos theta by 2. Hence the proof. Thank you.